Okay, so welcome to an introduction to multiplayer in Unreal Engine. The purpose of this course really is just to give an introduction to some of the features that come with Unreal Engine out of the box as part of the networking system, and it's targeting not so much CPP developers. If you haven't done networking before, it'd still be useful for you, but mostly it's targeting those disciplines who kind of need to know a little bit about networking and maybe making various mistakes or not quite fully understanding concepts that they're having to deal with in their workflow. Maybe designers who do a lot of blueprint work, maybe QA testers, etc. And just to give a bit of a foundation for people to understand what a lot of the terms that we tend to use when talking about networking in Unreal mean. So what we're going to be going over then is kind of listed here, talking about the different types of multiplayer modes that you have in Unreal. We'll be talking about how you get communication between server and clients, and that includes replication, RPCs, concepts like relevancy. We'll talk a little bit about client prediction as well. And then a bunch of terminology, things like NetMode and role and ownership that we may see thrown around a little bit too. And then I'll be showing you some editor tools, things that you can do in editor to simulate a multiplayer game environment as well. Then the second part of this will be a walkthrough where I've made a little test environment where I can kind of illustrate and demonstrate some of the concepts that we talked about. We'll build up a few examples, making mistakes along the way intentionally so that we kind of hopefully learn the common pitfalls or easy mistakes or misinterpretations that can be made. So let's go straight into this then. So in Unreal, really, you're going to have three different kind of multiplayer modes available to you. You're either going to have standalone, which means that you're playing on one machine. All you're going to get is local co-op at best, split screen. The second type is the most common type of server architecture that you'll have, which is our dedicated server. And what this means is you have a typical multiplayer server where this is a computer running a special server build of your game. And then clients, being other people's who want to play the game, will launch a client executable of the game and then connect to that server. And that server then is holding the state of the world, and the clients get that state of the world from that server. And then the third type we have is a listen server. And how this works is one of the players actually access the server too. So instead of having the server running on its own with no kind of viewport or players using that machine, instead, listen server, one of the players is the host. And so they're both hosting the server and playing the game on their own machine. And then other players will join their session, and that has some pros and cons as well. So let's just quickly mention those. So as we were saying on this listen server, then it's going to have a viewport and a local player. Local player meaning someone who's controlling stuff, and a viewport meaning you can actually see the world, right? And that one player will have an authoritative state of the game. That means that whatever they say goes, and any connected clients are going to get updates from that server. Also in a listen server, if you have anyone join your game, they'll connect as a client. This also has a viewport and a local player that they control, but that will be receiving the state of the game from the server. It's typically suitable for smaller multiplayer games, the pros being that it's cheaper. You don't have to host a dedicated server, especially if you're maybe a small indie studio trying to release a game. Investing into scalable servers is going to be an upfront kind of overhead cost for you, whereas having players be the ones who kind of host their own sessions can be a benefit in that regard. Where the cons really is that one player is going to have that much better experience than people who have to communicate over a network in order to speak to the server. It also means that there's a bit of integrity kind of side of things that can be questioned. If the person hosting the game is running any local cheats, they have access to the server and the state of the game, and so there's that less of a layer of security there. And so with that, we'll move over to the more common type of server architecture that we have, which is the dedicated server. So as I said, this is the idea that there's a machine somewhere hosting a server, and this isn't a machine where people are going to be playing the game on. It's actually a different build. You don't launch the same exe. It tends to be a special build, which will just kind of open a console application, and it's running all the logic, but it doesn't waste resources on showing what everything looks like. And so, yeah, this will kind of load in all the levels and the actors of the world, but it's not going to care about things like the UI, visual effects, audio playing, since there's no one there to kind of observe it. It's like if a tree falls and no one's there to see it, the tree didn't even need to fall, or we don't have to see it fall at least. Now, the client side of it, that's going to be what we're used to seeing as players in a game. Now, that will load in the level as well. Level streaming is a concept in Unreal which might dictate what part of the map loads in. That's not really replication. That's the client knows about all of the level already. And so when you move around, different parts of the level will load in, but that's not a networked process. The networking side is these changeable actors in the world that could maybe move around. If you can build stuff or if you can move things in the world, that's the stuff that tends to be replicated, because the location of that needs to be synced between the server and all connected clients to it as well. So it'll only load in replicated actors if they're relevant to that particular player. And we'll talk about relevancy in a moment, but just think about it as, does that player need to know about this particular actor at this point in time? And it could be they're the other side of the world, and so then that actor's not relevant to them. And so they don't get sent that information because they can't see it, and so there's no point wasting networking information sending that stuff across the network. So, yeah, you can think of this as multiple games running at once then on different machines. Typically, you can have a server, an n number of clients that connect to that. And each instance of these games needs to have a shared world that they're trying to keep consistent. And typically we have in Unreal at least, there is a server authoritative model. And what that means is the server has the final say on the state of the world, and connected clients will get updates. But the clients can actually send requests to the server and say, hey, I've tried moving my character. And then the server gets to choose, is this reasonable? Yeah, okay, I'll let you move. And then the server sends out that update to everyone else. So there is a bit of two-way communication, but ultimately the server gets the final say. So that's what we mean by server authoritative. Now, player connections. This is just a bit of background on how it works when you're connecting to a server, I guess. So the server is going to create what's known as a net connection, which is a type of object in Unreal for every connecting player. And this is going to be done per player controller. So the player controller is really the connection between client and server. It's almost like a special class when we're talking about replication and relevancy, and replication and RPCs and the likes. So communicating over the network. So this connection that the server makes for the player controller has various channels for communicating over a network, much like most internet protocols. So this will have a channel for voice comms, for example, if you've got voice over IP perhaps. And then for every actor that it needs to replicate out to that particular connected client, it will open another channel for it, so that it has a means to send information to that particular client. So an actor is going to replicate to a client if it's flagged as replicated, which is something I'll show you in the editor in not too long, and also if it's net relevant. And net relevant is just a way of, it's a set of rules we'll talk about later where we determine if an actor needs to be sent to a client or not. And what's interesting here is if we think of it as we open these channels for each actor opening, the fact when the server opens a channel for an actor, the client will then, that will be the prompt for the client to spawn that actor. And if the server closes that channel, then that will be the prompt for the client to destroy that actor as well. So the server's kind of having authority over the opening and closing of this channel. That's a bit of a techie look into the back end of it, and we'll start getting into some of these terms that we've been mentioning now. So first off, communication between server and clients. We've got a few concepts we're going to go over. We've got our replication. This typically covers, replication can be a broad term used to describe all of this. But when I mention replication, I'm generally talking about having properties on an actor. Let's say we've got a dog actor and it has an age which goes up periodically. We could replicate, that's a changing data, we would replicate that age to clients so they're kept up to date with how old the dog is, for example. So that's what I typically mean by replication in this talk. We then have rep notifies, otherwise known as on reps. This is our way to do reactive logic of when I get an update that my dog has gotten a bit older, I can do some logic. I might want to throw a birthday celebration from whatever. So it's doing reactive logic based on data changing. And then finally, we have a remote procedure call known as RPCs. And this is a way for you to directly call a function across the network. So the server can say, hey, client, do this, or hey, every connecting client, do something. And also a client can also make a request to the server and say, hey, I want to call this function on the server. And again, we would code it so the server has a way to kind of verify, are they asking for something reasonable or not? So they're the three broad terms that we're going to be looking at. And we're going to start off with this replication side of things. So actors can be flagged as replicated. This is done by turning on a flag called replicates to true. I can just quickly show, if I open up a replicated actor, I can just show you, if I click the top, there's a replication section over here on the right, and then we have a replicates property here. So that's how we say it's replicated. This makes the actor capable of replicating data or sending or receiving RPCs. RPC, remember, are function calls. So basically functions can be called over the network on that actor. The server is going to continually check all of the replicated actors, and then it has to kind of figure out, okay, has this changed? And do I need to send any updates out to the client? And this is one of the areas where it's a network performance cost in a game, that if everything was replicated, it's going to have to check over so many actors that it's going to impact your server performance. And also you're going to be having bad network performance, having to send out data about every single actor in the game as well. So with that in mind, there's a limit to how much network data can be sent per frame. So what that means is if we've got, let's just say 100 actors that are replicating, all their replicated data is quite a big chunk of data, and we can only send this much data. What that means is we'll send this much, and then next frame, we'll move on to the next chunk. And there's almost like a queue system, and there's some parameters we can tweak to control how often that stuff gets sent. But the key thing here is we can't really guarantee that all replicated data gets sent to the clients in the same frame. So you might receive stuff out of order. You might receive it not all at the same time. And so when we do our code, we've got to be aware of that. Now, there's some workarounds we can use. You can say we want a member variable, let's just say that the age in month and years and days. If we want all of those to be replicated together, instead of having 3 different members that we replicate, we could wrap those into a struct, which could be like a age info struct. And if we mark that struct as replicated, it makes sure that all of that struct gets sent together. You're not going to get a partial kind of bit of data sent. It has to be contain the whole thing. So that's one way you can kind of guarantee things get received together. Yeah, other things to consider then is that the server will prioritize what to replicate. And we can change some of these settings per actor to dictate how often things are getting replicated. But some of the stuff that's built in is the closeness to the player. Generally on that assumption that if things are closer, we probably need to see more updates. So you might have seen it in some games with the animation. If they're far away, you only get some animation frames playing. Or things are just a little bit more choppy, let's say. And that might be another similar approach to optimization of saying, hey, if it's further away, we don't really need that fidelity. And this is just a data-oriented kind of approach to that, I guess. And also how long it's been waiting in a queue. Because if everything can't get sent in one go, then we need to kind of process it the next frame. But we might get some high priority stuff come in and, jump in the queue. So there's some system to make sure that something doesn't get pushed to the back of the queue continually as well. So the 2 properties that you might want to look at in order to kind of change this. And also remember that it's not always about getting data sent out regularly. You might have something that is replicated that doesn't change that often, and it isn't time critical when this data gets to clients. So as a result, you might want to change these values so that it's slower, not just faster. So yeah, net update frequency and net priority. This is something that you're going to be able to find in the same replicated section where I've got replicates. You can come into here and you can see we've got net frequency and here net priority. And you can hover over them and you get some decent kind of tool tips on those. Okay, so let's talk about replicated properties then. So if you remember, both server and clients, they're different executables. Imagine there's a server running in, let's just say, in London, and then I'm playing in Birmingham, and so there's 2 versions of the game running. What's important to know is like both server and clients have all of the game files. We know what all the levels look like. We've got all of the data about what makes a particular actor, what the meshes in that look like for a character. The bit we don't know is anything that changes the state of it. So if my client will know what every outfit for a character in a game looks like, but I don't know which one it's wearing. So I get data from the server saying, oh, you're wearing the shirt outfit. And then what I get replicated to me is just a little bit of data saying, oh, you're wearing a shirt. And then I look up the game files for that on the client and display that. So you don't have to like send all of the data about the shirt in this example. Instead, we just send small amounts of data and then we look up that information on our client because that has all of the information for us. It's only the data that changes that we need to share. So when an actor is flagged as replicated, it doesn't mean his properties are automatically going to be replicated. So what I mean by that is this particular actor has replicates tick true, but if I just add a variable here called is cool, that isn't going to be automatically shared with clients. Replication just means this actor is capable of replicating and doing RPCs. If we want this to be replicated, we go in and we need to, let me just compile this. We need to say that this replicates by choosing it in this section here. We can say it's replicated or rep notify, and we'll talk about these in just a moment now. So broadly speaking, nothing is replicated. That's what you should assume. There will be some things automatically replicated in an actor. Like if you were to spawn an actor that is replicated and that gets sent to the clients, it's going to know the location in the world where to do it. You don't have to worry about setting up, like, is the transform replicated in that sense. However, we do need to manually flag any of these properties, as I said. When it comes to components, so here we have like a text renderer component. Typically, you're not going to be changing the replication settings of a component. A component will have its replication setup configured in the code class for that particular component. So if you need certain things in a component to replicate, that's something you need to speak to an engineer, or you need to go and have a look at the code yourself to figure out how you could make that bit of data replicate if it doesn't already. Some components will replicate information already, but a lot of them will not, and so it's really a case-by-case basis. You do have a flag in here. Will it show up for me now? I think it's replicates. Yeah, so you do have a component replicates, but just like I said with an actor, just because you say it replicates doesn't mean every bit of data inside of it is then going to be replicated over the network. It needs to be specified inside of the definition in CPP in this case, saying which members of that component replicate. So it's not a case of just ticking this box. So it's worth being aware of that. Okay, so the replication condition is a way for us to control who it replicates to. So if I go back to this is cool, if I go replicate, let's set it to replicated, then we have this replication condition. In here, you can choose some settings in here if you want. You don't have to, but this is more for special case things. For example, you can choose initial only. That means replicate the initial value of this out, but then we never need to send any updates again. There's also another one where we have owner only. So that means only the owning client of this actor will get information about it. So if I say it's a 2-player game and player 1 chooses to spawn an actor that they have ownership over, let's say they place their bag on the floor, if we want, we can make that bag only visible to that player by only replicating it out to that player. So the second player wouldn't get that information sent to them, they wouldn't have the actor spawn in from, they wouldn't really be aware of it. So there's things that we can do along those lines as well. Now this isn't for like actor replication generally, so this is property, so that is the idea of a bag actor is maybe not the best example for a property, so apologies for that, but hopefully you get the concept. You can flag actors as having replication conditions as well, so it is relevant, that example in that case. Okay, so it's also worth noting that a client doesn't receive all changes made to a replicated property. So let's say we had an actor that will change its value many times over 1 second. But if we limit that actor to say, hey, we only want you to send out updates once every second, we don't have to, the server isn't going to send each one of those updates to the client. all the client's going to get is the value it was on when it was sent out. So the example we gave here is if we had a timer that's incremented 1, 2, 3, 4, 5, 6 up to 10 over 1 second, the client would only receive that 10 if that's where it's got to at that point. It has no idea that it went 1, 2, 3, 4, 5. All it knows is it was initially on 1 and now it's on 10. So you don't get that full history. You only get what's sent out. So that means you can sometimes change a value a lot that's replicated, but limit how often it's replicated. That way you're not sending a ton of data over a network and it's just getting the most up-to-date correct information. So on the server it can be updated a lot, but clients just get less often that updated information. Now it's also possible for clients to change data on a replicated member, but it's not really recommended here. So what that means is if I flag this is cool variable as replicated, generally I want to be changing that on the server and have the information sent out to the clients. Now player 2 could manually, if we set up code for player 2 to run this, they could manually change that. Say the server set is cool to true, and then it gets sent to them, it's set to true. Technically there's some code that could run on their client that sets it back to false. But then we have a situation where we're not in sync between server and client, and we generally want to avoid that situation. It might be used for some situation where we're doing client prediction, but still, I'd use it very scarcely if you're considering doing that. Now, the final thing, we've been talking about actors replicating and their properties updating, and how, you know, there's sometimes a queue and sometimes it doesn't update as often as you'd think, and that you can control how often it gets sent out as well. Now, the movement is something that you would want to probably be smooth. You don't want it to update once, let's say like 3 times a second, because it'll be really janky moving down the screen. And so you can choose to replicate the movement of an actor. So if I just go back to this actor here, there is a tick in this section for replicate movement. So if you do that, it'll automatically send updates out about the transform of the root component of this actor. However, if you want smooth movement, that's where something like the character movement component comes in, because that does something called prediction as well, which means that even though we're waiting for updates from the server, it manages to, well, it's technology. It also uses RPCs to communicate quickly, making sure that things don't get too clogged up. But secondly, it does prediction. It'll take which direction were they facing before, how fast were they moving before, where will they probably be in 0.1 of a second, and it will simulate the movement while it's waiting for updates from the server. And that allows it to look a lot smoother, but it does mean in some situations where if you've got high latency, that a player could look like they go in one direction and then all of a sudden the server updates them, and then you get that kind of rubber banding effect that you may have seen in games. So that's one way that you can see that sort of behavior. So that's our replication of properties, and what's tied very much to that is rep notifies. So rep notifies, as I've mentioned before, is a way for us to show some or perform some logic as a result of a replicated property changing. So to enable this, instead of using the replicated option in this dropdown, we instead do rep notify. And when we do that, if you look over this section of the screen where the functions are, if I choose that, it makes a new function for me automatically. And this is what will get run on the client when it receives updated information from the server about this particular property. So you can see I've just got a function that I can implement. I can do whatever I want in here. Now, the server, this is quite an important little caveat here. The server only replicates to the client if the value is different to what the server last sent. It's something called shadow data. I'm pretty sure it's on the server. It checks this rather than the client. But if you know any different, feel free to let me know. So the idea here is if the server has this, let's use this silly dog's age as another example again. If the dog is 42 and then we tell the dog it's 42 again, it's not going to send that information out to the clients again because the value hasn't changed. So that's like an optimization thing, but you can get caught up in some funny situations where you don't actually get the rep notify when you would expect it to. We'll go through an example of this in the walkthrough section a little later. So generally, the reason rep notifies are great is because it gives us an approach to kind of run functionality as a result to data changing. And one way that you could look at using this is, instead of replicating regular changes over the network, continual changes, if the changes that are about to happen are deterministic, meaning it's predictable, it will be the same 10 times in a row, the same thing will happen, then instead of replicating all of that information, we might be able to really simplify it. So in this example here, we have a door that's going to open. Now the position of the door is going to be rotating every frame, and that might be over, let's say it opens over 3 seconds. You're talking, you might have 180 different kind of frames of run if it's running at 60 frames per second, say. So 180 updates in position. We could send those over the network. Let's say that we happen to be sending one network update every single frame as well, just for argument's sake. That's a lot of network traffic that we're sending, and a lot of on-reps that we're receiving and updating where the transform is, so that the client updates its door position too. Now, if we try to minimize that and say, hey, okay, let's just send it out 4 times a second instead, then the client door is just going to open really chunkily like that, unless we write in some logic to kind of interpolate between values or predict, like I said, the character movement component does. But what we can do, because it's deterministic, what we can do is instead, we could just send out information saying, hey, the door is open. And we know both client and server have a function that says how to open the door. It rotates it for 5 seconds or whatever I said, or 3 seconds I said, from 0 degrees up to, let's say, 110 degrees. They both know how to do it. So instead of replicating the location around, what we do is we send out a message to say, oh, client, the door's open. And the client will then go, oh, okay, what should I do? The door open variable gets replicated, and then we have an on-rep or a rep notify function that says, okay, when it gets set to true, I want to rotate from 0 to 110 degree on my z-axis. And then if you get an on-rep and it says the value's just been changed to false, you can just do it backwards. You can say, I'm going to rotate from 110 back to 0. And we're only replicating out that tiny bit of data, which is true or false about that bool, instead of 180 different frames of rotation data. So that's the kind of benefits we're looking to make when we're using on-reps or rep notifies. And it should be your first port of call of, can I achieve the logic I want to happen over a network via a replicated property? Replicated data is also reliable in the sense that it will get received by the clients. That's going to be slightly different to RPCs that we'll go on to in a moment. The only thing to consider is, let's say that the door, we said this door should be open, right? But player A is miles the other side of the world. So they may not be relevant to that actor. We're still going to talk about relevancy in a moment. But remember, it means that does this player care about this door? So while they're at the other side of the world, they don't really care about the door. But let's say that, so the door was shut and then it got opened while they're outside of the world, let's say the boundary. Now when they come into relevancy of this, when they get close enough to it, what's going to happen is that door would have been closed before, and now they get sent the newest update information about it. So it says, oh, the door's open, by the way. So that door's going to swing open now. Now the end result is good, the door's open. The bad thing about that is, let's say I was a player arriving in this area and I see a door open, I might think, oh, is there another player here? And I might be really cautious then if this was like a multiplayer shooter, say. Whereas actually that door didn't just get opened. It got opened 20 seconds ago, but I've only got that information now when I got close enough to it. So that is one of the kind of downsides to it. Well, it's just the way it works, but it's worth being aware of that sort of thing. It can also be... the same thing if you're playing any audio as a result, that audio is going to happen when they come into relevancy, and that can be really confusing to a player. Now, one little quirk between a CPP and doing it in Blueprint is if you change a replicated value on the server. So if I'm running server code and I set the value of a parameter on the server, that will call the rep notify function that I've defined. Remember, the rep notify is what I define in here. So if I set is equal to true on the server, it'll call this. Now, if we did it in CVP, however, that's not how it works. You have to manually go and call that function if you want it to do it. So it's just a little quirk that is different between Blueprint and code for anyone who's familiar with both. Okay, so next up then, we are going to be looking at RPCs. So RPCs then is that way that, as I said, we can call a function across the network. So a server can say, hey, clients, I want you to run this bit of logic on this replicated actor that you've got. So let's say that there's a dog and it's barking, right? I don't know why I'm using a dog all the time, but whatever, right? So the server might send out information and say bark, and that would be a kind of more time sensitive thing where we want it to be immediate. All clients could receive it if that dog is replicated and they're in relevancy of it. And then finally, what's good about it, but also can be seen as a bad thing, is if they're there to receive that event, it'll bark. But if they're not, let's say they're miles away and they're not relevant, and when they come back into relevancy, they're not going to get that event. So it's kind of fired. If it's relevant to players, they'll receive it. But if not, that's gone. So that's a blessing and a curse, because if it's something cosmetic or very time critical, then sure, that might suit your situation. But if it's something that's driving gameplay logic, like the state of the world might look wrong then, like the door opening. A player, we send out an event saying the door's open, the player comes in, and then it looks like that door's closed, so they're not going to walk through it. But technically on the server, the door's open, so they could have walked through it. But it was just we lost that sync between the server and the client, and that's something we're always aiming to avoid when we're designing our multiplayer games. So there's 3 different types of RPCs that we can kind of work with in Unreal. Let me just have a swig. So we have run on owning client. So these, let me just show you where they are in editor. If I was to go and make a quick function, I think I've got one that I could do here. Yeah. Within this function here, you've got this replicates. So it's a way you can set a function to be either run on server, multicast, or run on owning client. And they're the options that I'm talking through now. So run on owning client, then what that means is it's going to be a server telling a client to run a function. This is a specific client. You can call this on the owner of an replicated actor here. So because it only runs on the one client, you can't specifically say which client it wants to be. It will automatically run on the client that owns that particular object. We then have a run on server RPC. This is going to be an important one. This is our only way that a client can tell the server some information. Replication of properties that we've been talking about is purely server to client. Running, if we want the client to tell anything to the server, it's got to be done via this way where we do RPCs. So this is where a client calls a function on the server. This might be something when you press click in order to shoot your gun. The inputs is all processed on the client side because that's where the mouse is connected to. The server doesn't know about that information unless we tell it. So when I click, I then want to shoot, but I need to tell the server to shoot because it's server authoritative and the server is the one that decides what happens or not. So I would then do a run on server RPC to say, try and shoot, please. And then the server would go ahead and process, are they allowed to shoot, blah, blah, blah. And if they're happy with it, they will shoot on the server and that gets propagated out to everyone else in the game then. And then the final type we have here is a multicast RPC. Now this is server going out to clients again. It also runs the function itself as well. So when a server calls a multicast RPC, it will run a function on the server and any connecting clients. So if a server detects that a player has died, it might call a function to turn on ragdoll on all clients. That's just an example. That might be something whether or not we want to do ragdoll on the server because you tend to run physics simulations that aren't game critical on the server. Maybe it's not the best example, but it still gives an idea of something we want to broadcast out to everyone. So RPCs can only be called on replicated actors, keep that in mind. And ultimately, they need to be owned by the player controller. And we'll talk a little bit about ownership in a moment. But this is due to what we talked about earlier in the connection section, where a net connection is associated with a player controller. And so that player controller is our way of communicating with the server in a multiplayer game. Now, RPCs can be impacted by relevancy, as I alluded to earlier already. So multicast RPCs will only be received by the clients that are relevant to that replicated actor. If we, however, do this this one up here where we had the run on owning client RPC, however, what we're able to do, basically you don't need to worry about relevancy in that situation because it will be received regardless. So essentially an actor channel needs to be open for multicasts to work. Now, what's interesting, the reason it would still go to running on an owning client is if a player controller owns a replicated actor, that actor will remain relevant to that actor always. So that channel's always open. So that's why it works that way. But as a general rule, you can think of it as multicast, which is the most common type of RPC you'll see, in my opinion. Those will be only received by players that are relevant. And as we mentioned, it's not going to be fired again when the player comes into relevancy. It's lost forever. And so that's why sometimes we would use properties with a rep notify instead, because it's a little bit more advantageous. So reliable and unreliable RPCs. Now this is a property we can set when we are making one. You can see here there's a tick box for reliable. Now it may seem a little bit silly that why would we ever want to make an unreliable network call. Unreliable here means we'll try and send it, but if it gets lost, we don't care. But the reality is, when we're trying to kind of monitor and kind of improve network performance in a game, there's certain things, if they're not game critical, it's not going to break the game if it doesn't get received by the client. This might be maybe a little bit of VFX, a bit of sound or something like that that isn't gameplay critical. We could miss, if that doesn't get received by the client, it's not going to ruin the game. It's not going to break the game for them. And so there may be things that we do accept. And the reason that's a benefit is because we don't have to wait for the, what happens typically if it's a reliable one is the server sends out the RPC and then waits for a response to say, oh, I received it. So if you think about that back and forth, and then it'll have to, if it doesn't receive that after a duration, it tries to send it again. That is extra bandwidth, and it can, if you think about that happening lots of times, it could start causing more of a bottleneck for your networking side of things. So that's the general thing. It's okay to do reliable ones, but it's just worth considering, could it be unreliable if it's not gameplay critical? So in summary then, RPCs are quick but a little bit costly. I think one thing that's nice about RPCs is they will get sent out as a matter of priority. I think they're always sent out when they're called, whereas like we talked about replicated properties earlier, there's only so much data that can be sent, and there's a bunch of rules on replicated properties that control how often things will get replicated out. But the RPCs are faster, but as a result they are also more costly, and that's definitely worth keeping in mind when deciding which one you should do. The other thing that's quite nice about RPCs is they actually get received in the same order they were fired if they're reliable. So that's pretty cool. Like it says up here, the order in which they're called was respected. With replicated properties, we don't have that guarantee. As I said, things can get sent partially, and you don't know exactly which order things are going to get received to you in. Whereas RPCs do give you that way of, if you need logic A to happen, then logic B, then logic C. If you're doing those via reliable RPCs, and you call them in that order, they will be received in that order on clients as well, which is quite important. But broadly speaking, yeah, we want to consider, can we do the logic with replicated properties and rep notifies? If we can, try and do that. But otherwise, RPCs are an effective way of communicating too. So we've talked about this term relevancy quite a lot already. So we're going to have a bit more of a dive into what this means now. So a term to describe if a connected client needs to receive updates from a replicated actor. So as I said, this is like, does that client need to know about this particular actor? It could be that they're miles away, or it could be a special type of actor that you only want one of the teams in your game. Let's say you have 3 teams in your game. Maybe you only want a certain actor to be visible to the team that owns it. And so that only gets sent to those. That term relevancy encompasses all of those situations. It's whether or not this actor needs to be sent to a particular client. So by default, it's done by distance. You may see this net cull distance squared property. So if we go into the general actor settings here, And then we look here, we've got net call distance squared. This is a giant number here that represents how far away you need to be in order to for this actor to be considered important to you or relevant. So you can modify these though. That's not the only way. You can turn that off, you can override it, and you can add to it too. So always relevant is an option, but again, so it's a tick box here, always relevant. I could turn that on. That would mean that no matter how far away you are, it'll always show up. Now, this is costly because one of the reasons in a larger game that we can get away with having so many things in the world is not every connected player needs to know about updates about every single actor in the world. But if we made every one of them always relevant, then we are in that situation where every single player needs to know about every single actor in the game, and that is going to have performance costs, not just networking, but your server having to go through all those actors and send the stuff out as well. Does add to that kind of CPU performance. Now, the other type of things we can do is we could maybe replicate just to owner, as I was saying, maybe in a team game, or if you spawn something that you don't want other players to see in a competitive game, perhaps. And then finally, you can override the isNetRelevant4 function, and this is done in code. I haven't found a way to do it in Blueprint, unfortunately, but in CPP you can ask an engineer or dive into the code yourself. You can override on an actor this function, and you basically change the rules. The default rules for this is look at the location of where the player is or the play controller is, look at the location of the actor, is the distance between them equal or less than this net call distance. That's the basic rule, but you can add in extra stuff into that or override it if you want. The only other exception to be aware of, and this has come up with a colleague of mine before, where if you hide an actor, you set is hidden in game, and if you turn off the collision on the root component of that actor, it will not be relevant to any client. Purely the way this is built in is if you can't see it or you can't interact with it, then why do we bother sending that information out? So it shouldn't cause too many problems, but it's worth being aware of that as well, at least. Now, entering and leaving relevancy. We're going to talk about relevancy as if it is just this distance for most of this talk now. But do keep in mind it can be different than that. But I'm going to talk about entering and leaving or exiting relevancy. So think of this as a circle around the player. And when you move in and out, if you move in it, you get updates. Let's say a circle around an actor, let's say. And when the player gets within that circle, it gets updates about the actor. And if it's outside that circle, it won't get updates about the actor. But yeah, just do keep in mind that the entering and leaving relevancy term kind of implies it's always based on distance, but it's not always. You can override it, as we said. So there's a few things that happen. I've alluded to some of this before. So when an actor is relevant, so it was relevant, so say you were within that circle of distance, and then you leave that circle of distance, so it's no longer relevant, the actor channel is closed. We talked about that concept a little bit at the start. And as a result, it's no longer going to be replicated to that particular client. There's a little bit of a delay. It doesn't instantly pop off the screen, just in case you're going back and forth over that boundary, so it doesn't keep destroying it and having it pop back in and over, but it will destroy it after a short delay. There's some special rules in here. So level actors and actors that are owned by the client, they will remain in the game. So they're not going to disappear when you go out of the view. But all other replicated actors will be destroyed when you go out of the distance of their net calling. Now, when an actor wasn't relevant, but then becomes relevant again, so think of this as walking into that circle around this replicated actor, it will immediately be spawned into the game if it was no longer there. So again, for level actors and actors that are owned by the client, it will receive the most up-to-date replicated properties. But for all other replicated actors, it's going to spawn a new version of that actor in. So it's interesting to keep that in mind, that it actually spawns a new actor in when you get close enough to it. And when you leave it, it can destroy it. In this situation down here, at least, right? And so that means when you come back into relevancy, you're going to get begin play called again. It's not like hidden and kind of put into a sleep somewhere. It's literally destroyed and recreated on the client. The server, it always exists, but on the client, it's going to remake it And so if you put logic in begin play, remember that's not going to happen just at the start of the game. In a networked game, that'll happen when it comes back into relevancy. So if you have some fancy spawning animation when you first spawn into the game and birds singing and whatever, that would happen every time you come into relevancy as well in that situation. And that might not be desired behavior. Now, client prediction then is it's hard to be concise on this topic. And there's no one right answer for how to do client prediction. But the reason, let me explain what client prediction is then, and I'll give an example at least, just so you understand what we mean when we use this term. So the server is authoritative in this multiplayer dedicated server setup that we've been talking about. And so any client input, so if I do some action in the game, I click or something, or I press any buttons, that will need to be sent to the server. And then the server performs that logic, and then that logic gets replicated out to all connected clients. Now, as a result, since we're over a network, even though internet speeds are quick these days, they're still going to take a bit of time, and that time is noticeable in most cases. It depends what you're doing, but it's definitely something that can be noticed in a reaction precision kind of speed important game. That was a crap phrase, but you're with me, I'm sure. So client prediction then is a technique for us to change the state of the game immediately when the client presses a button. So to them it feels good, it looks like it's reactive, but actually the server hasn't got that data, other clients haven't got that data yet, but for the person playing it will feel better. Then what happens is the server still gets sent the information, they verify it, run the logic, and it'll get sent out to everyone else then. But it's a way to make it feel better for that particular player. It can be good, but it can also lead to some bugs as well if you're not careful with it. So an example is shooting a gun. If you click the mouse and you had to wait 0.2 of a second before the shoot request is sent to the server to perform logic and then send out to other players, it would feel a bit bad. You click and then it's a little delay and then it goes bang. It's like playing a game with some bad Bluetooth headphones where the sound is really delayed. It just feels off. So instead what we can do is on the client who shoots, we can play that shoot animation immediately, and then when the server performs that logic and replicates it out, the owning client doesn't need to react to it anymore, but everything else can go ahead and just react to that server data being sent out. So that's an example of it, but it's going to really vary based on what you're doing. And also you might want to handle what happens if the server doesn't approve of it. So we got a little bit of an example here. So imagine in that shooter game, blood splatter. So if we shoot again, and on my screen, I'm aiming at someone and it looks like my crosshairs on the character, right? However, this is my client representation of the world. It could be slightly out of sync due to networking, latency, packet loss, things like that. It means that my world might be slightly out of sync with the server. So when I request to shoot, I'm going to immediately play my shoot animation so it feels good. If it looks like I'm shooting them, I'm also going to play the blood effect, because it'd be a bit weird if I shoot them and then blood comes out half a second later, right? However, then when it gets sent to the server's got the real state of the world. And the server might then go, well, they are looking this way, they shot, but the player they're shooting at, it's not actually anywhere near where they're shooting. You know, it's a good foot aside. So we don't think that's a hit. So the server isn't going to replicate to the other clients that the player's been hit. It's not going to change their health. So that's okay, you think, but then for the person who took the shot, they're a bit confused because they shot the player, but they're not dead. And that can cause a bit of frustration in players, definitely, where you're like, I swear I hit them, and then you look at their health after you die and they're on full health still, and it feels like the game's a little bit broken and unreliable. But it's a really tricky balance of trying to make the game feel good and have it have a true authoritative state from the server. Okay, so now we're going into, it's already been a little bit technical, I agree, but we're going to have a little look now more at some of the terminology that and some of the kind of the nitty-gritty, I guess, of how we can identify or differentiate between a server or a client, because realistically we need to know when we're running code, is this on a server or is this on a client? And the reason for that is because in Unreal, even though we package out a separate server application versus what the players are launching up on their PCs, remember I said the server one would be like a console application, instead, even though there's two different packages being made, it still gets done from the same code. So if we have a gun actor on the server, but when you shoot it does a trace out and detects if it's shooting someone or whatever, that will also, the same code file that defines that is going to be on the client as well. So we use that. It's not like we have a server version of everything and a client version of how we write the code. We do have different actors in the network game where they'll be on the server, there'll be one version, and we make a copy of it and send it out to, we send the data to the client so they can make a copy of that to simulate the world that they're trying to emulate. That side of it, yeah, we do have there's different versions of it. But if we talk about the code where we define the rules of what makes a gun, that stuff is shared. And so what often we have in code is we need to differentiate or branch or gate our logic to say, okay, well, if this gun is running on a server, we need to do thing X. But if this gun is running on the client, we need to do something else. And this could be an example. Let's say we have a gun example where we're shooting. If we're running that logic, the fire function gets called on the server. Then we want to do our trace, and we want to then deal damage. And then we want to replicate that out. Now, if we're running it on the client, we still maybe want to do the trace. We want to play a blood splatter if it hits. We can't change the health of other players, so we won't do that. And we might want to play our flashing animation on the nozzle. We might want to play the audio that we've shot. We might want to do recoil to move the gun location. So that's going to be something to consider as well. So that's two different types of logic, but it's all happening inside the same actor. So that whole little story was to help you realize that we need a way to know, is this running on a server or is this running on a client? Or is it running on standalone? Because you can also have games that work in both single player and dedicated server mode. So you can support both of them simultaneously from the same code base. So given some examples here that we might branch out. Yeah, I don't need to go over these because I've already given an example here. So some classes, it's worth noting, will only exist on the server and the client. So an example of this is the game mode. This is one of the Unreal Engine frameworks classes that will exist for you when you play any game. And that game mode exists only on the server. We only spawn it on the server. So that's going to be gated behind some checks. If we're on the server, spawn it. If not, don't. An example of a client or standalone stuff, think of this as where there's a viewport and a player controlling the game, then we need a HUD. A HUD is the thing that a class that we use to kind of communicate with the UI for a given player. So we can use the NetMode, which is a term we'll talk about in a moment, that belongs to the world that you've joined, and we can use an actor's role in order to determine what is this actor, who has the authority to change information about it, and are we on a server or are we on a client, or are we on a listen server, or are we in a standalone game. So we'll determine that by looking at these few properties coming up now. So the NetMode, let's start with this. So when hosting or joining a game, the world that you're going to be joining will be assigned a NetMode, and then you can query that world's NetMode in order to find out some stuff. So how you join the game is going to dictate how that world is assigned a NetMode. You don't need to see this, but just so you understand what's going on under the hood, that is. But the things you may see are these terms: standalone, dedicated server, listen, and client. And this goes all the way back to the different multiplayer modes that I told you about right at the start. So the single player is going to typically be assigned a standalone NetMode. Now, if you're doing multiplayer with no viewport, no local player, it'll be a special build, and it allows clients to connect to it. It's going to be assigned a dedicated server NetMode. If you're running one of those listen servers we talked about earlier, it's going to be similar to standalone, but it'll allow players to connect to it as well. And then the final one would be a client. So if you joined a game via a URL, instead of when you launch the game, it automatically just loads up a level for you. You've instead said, okay, go to this URL and let a server tell me what level to load. If you do that, you'll be assigned join a world with a NM client NetMode instead. So you can check these in Blueprint, in code, in order to figure out, okay, is this bit of logic running on a server, or is it running on a client, or standalone? And there's some convenient functions we'll go over at the end that help explain this stuff as well. Alrighty, so let's go down to role then. So roles are something that are kind of assigned to an actor. So you can ask an actor, or when you're in the logic for an actor, you can kind of get your role from that. And what's interesting here, or confusing initially, I guess, is that a single actor, let's say that gun example we used earlier, there's a gun on the server and then there's a gun on the client. There'll be a version of it and the data is replicated between them. But that gun will have a different role on the server compared to that same actors on the client. That will have a different role. But that's important to us, because sometimes we want to know, okay, we know that we're looking at a particular gun, but we want to know who has authority here in order to tell the gun to do things. So authority means like I have the right to change the value for this actor. So in standalone, if you think about it, if we're playing a standalone game, non-multiplayer, you can do split screen, but that's about it. There's only one game instance running. There's only one .exe launched, right? And so we don't need to send out updates to the world and keep them in sync with everything. So that means all of the data is on one computer, so we have every right to change the data on that computer. Now, in a dedicated server, since it's a server authoritative model, like we said, the server's the one that's going to have that final say of what gets to change, and then the clients get sent out updated information about it. Now, if we're looking at clients, then the clients typically won't have any authority over replicated actors. So if the server has a replicated actor, that like dog from earlier, and tells it to bark or whatever, it can make the client version of it bark, but think of it as the client isn't having full control over it. The server needs to tell it when to bark, and therefore it doesn't have authority over it. However, if on the client you spawn something that the server doesn't need to know about, so let's say there's like when you shoot your gun, a smoke puff kind of thing flies up in the air. The server doesn't need to know about that. So if you spawn a little actor that has floating PFX, that would be something you have authority over, because it's not replicated. The server didn't spawn it or tell you to spawn it. You've actually just manually said, well, if I shoot my gun and I'm on the client, I want to spawn one of these. In that situation, a client would have authority over that actor that had the particle effects in it, for example. So not having authority typically means that it's a replicated actor that you've received via replication, and that actor, the server has authority over it. Now, the term proxy comes up when we're looking at roles. So far we've talked about the role of authority, but there's also two roles: autonomous proxy and simulated proxy. So autonomous proxy is for owning clients of an actor that the client will give input to. So your pawn and your player controller have the role autonomous proxy if you're the one controlling it. So imagine a two-player game. I'm playing with my friend. We're both in this dedicated server game. So the server has everything that we need to know, and it's being sent out to both of us. For my particular character in the game, I can see my friend's character as well, but that particular character, if you think my game application has two characters on my screen. One of them I control. One of them is a representation or a proxy of what my friend is controlling. Now, there's a way for us to differentiate. In my game code, I can differentiate then between which is the one I'm controlling and which is the one that other players are controlling. And that's where this comes in. So autonomous proxy means we have some autonomy over giving input to this. This is our pawn. And simulated proxy means this is the simulated will, if you will, of other characters in the game. But we don't have any kind of authority over changing or giving input to how they're moving on our screen. There is one more net role that's not listed here, which is there's one more role, not net role, associated, which is a role of none. And you'll see that come up in certain places. I think a level actor. So just imagine a tree in your world that isn't replicated, it doesn't change. In a multiplayer game on dedicated server, the server will have authority over it, because the server's the boss, it gets to change anything it wants. But all connected clients, if it's not replicated, they will spawn that tree because it's part of the level data. So they know the tree belongs there, but ultimately they don't, as it's not replicated and they're not the boss because it's a server-based game, it will have a net role of none in that situation. So you do see it sometimes. Okay, and finally we go on to ownership. So ownership then is something that kind of belongs to an actor. So on an actor, you can set an owner, And this often comes into play with RPCs, because I mentioned earlier that we have a special class when it comes to networking, which is our player controller. And that's the thing that's owned by the connection between the server and the client. And so anything that's owned by that, that is going to be allowed to communicate through the player controller to the server. That's one of the main reasons that owner is used in games. Also, some of the settings I showed you in Unreal, sorry. One of the reasons I showed you earlier was in some of the rules you can set on a particular actor. In the relevancy section, you can choose whether it's only relevant to owner, for example. So based on what class you set as that owner, that's going to take that into account as well. What actor, I should say, you've set as the owner. So consider interactions now, because we're going to talk about, well, why do we want to do RPCs? So one of the most common reasons we're doing a client to server RPC would be to take our player client side interaction where we click a button or use the joypad, and we want to send that kind of input, we want to convert that into an action on the server. So with a client, if we think of some form of interactable here, where I go up to something, I press E, it tries to interact with what's in front of me, the client's going to initiate that interaction, and then we need to inform the server about it. So if we let's say I was going to pick up, let's say, a dog, because we've used the dog the whole way through, why not? So I go up to the dog, I press E, and I'm going to pick up the dog. Now, if I try and let the dog send an RPC to the server and say, oh, okay, I need to be picked up because the client's tried picking me up, that's going to fail because the dog isn't owned by the player controller. The dog is just something that lives in the world. The server replicates it down to us. I have no ownership over that. However, if I say, when I go to interact and pick it up, instead of picking it up on the client and saying, dog, tell the server about it, I say, all right, I as the player, I'm going to tell the server I want to pick up that dog. What happens then is, because we are owned by the player controller, it can send that RPC up to the server, and the server can go, okay, they're going to try and pick up this dog. It does it on the server, it gets sent out to all clients. It looks like the player's just picked up the dog. And so, yeah, that's one example where the ownership would come into it, about thinking, where do you do your RPC? It's worth mentioning that an actor that is owned by a player, therefore, will always be relevant to that particular corresponding client. So if let's say now that I have the magical ability in my game to spawn a dog. So if I press my F button, it's going to spawn a dog on the floor in front of me. When I spawn it, I can pass in an owner and say, okay, who should be the owner of this dog when I spawn an actor in Unreal Engine? Now, if I'm the owner of it, or the player controller is, when I say I kind of mean either the pawn or the player controller. That means then that that actor channel will always remain open, and therefore I'm always going to get updates to it as well. So then that dog could therefore send RPCs to the server. But yeah, just an example that you can set the ownership on something. So we're just about coming to the end of this theory part here. Just wanted to show a couple of editor tools that we've got and things in the editor that can be useful. So first off, you can choose that some of this might be basic if you've used Unreal before, but you can choose to play a simulated multiplayer game in the editor. So I'm in Unreal Engine 5. It's similar buttons if you're in Unreal Engine 4, but if you press this ... by here, you get choices down here of how many players you want to play, and you also get to choose this NetMode. So here, if I want to play a single player game, I could press standalone, change the players to 1, and I could just play as if it's a single application running, no networking needed to be considered. But normally what we'd do if we're testing multiplayer in a dedicated server environment is we would set the number of players we want, and then we'd go and play as client. And if I press play now, you'll see that it'll pop up with 2 different windows for me representing each of the clients that I've got. Okay, so that's one thing to be aware of. What's actually handy is there's a setting in your editor preferences where you can allow games to be joined when they're already running. I only found this out recently as well. So is it join? Yeah, allow late joining. This tick box here, what that does is if I was to set this, let me just change my level quickly as well to one where I can actually move around. So if I go ahead and change my amount of players to 1, and then I go ahead and press play. So I've just got 1 player in a networked game at the moment. The window behind, because I've actually told it to launch in a new window. This is not actually the playing game. This is just showing my level editor now still. Okay, so you can disregard that. So this is just one player in the game, but now what I can do is I can go ahead and I can press this play button again, and it spawns another client for me. So now I've got a second client, and we can see the original player by there. Let's just open up the other window, and now we've got 2 players in our game. So that's quite handy, especially in networked games from experience working in proper shipped games that do multiplayer. A concept of joining in progress, joining a session that's already running, is an area where a lot of bugs can come up, because a lot of our logic when we code it assumes, okay, when it starts, we want the player to do this, this, and this, and we assume that like everyone is there when something starts. But sometimes a player will join midway through something, and we need to make sure that our replicated data will set up things in a way so it looks right to that player. So being able to join in progress like this to see how, look out for any bugs is useful, and it saves you having to get a real build kind of built up and testing it, launching clients at different times, and slowing down your PC while you run a server and 2 clients at the same time, which is something you have to do quite often in work. So yeah, that is allowing joining in late. You can also simulate latency, which is really important, because I think what most people do when they might know that you can play an editor and you can choose the number of players. So I want to play a 2-player game, great. But what they tend to have is in editor preferences, they haven't changed these network emulation settings. So what that means is if they have gone, I think it might be defaulted. If it's off, it doesn't use any of them. So let me just change these to 0 now. What that means is when you're playing, you will have 0 latency. It's all happening on the same machine, so it actually can all happen immediately. So my player movement is super responsive. When I move, I'm controlling the character on the right. You can see that it's updating the character on the left screen as I move really kind of instantaneously. And any actions that I end up taking will end up happening immediately too. But if you want to simulate a more realistic environment where things aren't as ideal, you can go ahead and use these drop-down settings in here, where you have average or bad. Let's just put it on bad for now, and then let's relaunch. And what you can see here is now when I move around, can you see there's a delay? I'm moving to the right, and there's kind of a little bit of a stutter afterwards. And that's quite useful, because sometimes having a delay on packet loss and things like that can show that if you slow to react to data, that it let's say that multiple bits of information is being sent out to the client. So part 1 of the data is meant to be sent, but it gets lost on the way, packet loss. But then the data is changed again on the server, and it gets the next bit of information and the most up-to-date bit of it. I'm not too sure if it will resend both of them in that situation, but let's say it doesn't. In that situation, it would have missed that one stage, even though you thought it shouldn't have missed that stage. So it's something for you to kind of consider. And I think it's just always worth trying to play in in bad latency conditions, just so you can see how does it react for those players who don't have that super fast internet, because we want to make a game that works well enough for everyone, and maybe it'll be super great for those with a great connection, but it needs to be playable for people playing perhaps in different countries based on where your servers are going to be hosted as well. Okay, so that's the network simulation, which is pretty useful. And then the final thing that I want to show, something else that I learned recently, is when you're playing a multiplayer game like this, quite often, if you're used to Unity, when you're playing a even single player session, this world outline is a really nice way to look at, okay, let's see everything that's going on in the world, and you can actually click on things in the world as well. But it's a little bit different in Unreal, where like I'm clicking on these, but because the game's running, it's like, well, which version of the actor am I clicking on? Is it server? Is it client? Now, what you can actually do is you can change in the settings up here, choose world, and you can choose which one you want to look at the moment. So I want to look at the server, and this gives me all the actors that are available on the server. And just for example, we should now be able to see that we have player controller 0 and player controller 1 for both players. Server's the only one who knows about all the player controllers. The clients are only going to know about their own one. So if we go ahead now and change the client, you can see that in this list, we only have 1 player controller here as well. So it's quite useful, especially if you want to maybe check the state of some variables, perhaps based on what world you're in, or just check that things have spawned. Then I think that's pretty a useful thing to be using, and something I learned about far too late. So yeah, that was the final little bit in terms of the useful editor tools. And then the final thing before I wrap up, we've got useful nodes and a little bit of common mistakes that I want to just go over quickly. So the useful nodes are going to be relating to when you're doing blueprint logic. So if I was in my character, what we can do in here is when we're performing any type of logic, forgive me, my mouse is a little bit janky when zooming in at the moment, you can do some branching behavior based on some of these things that we talked about earlier. So if you remember, we were talking about our NetModes, standalone, dedicated server, listen, and client, and we were talking about our roles, which is if you have authority or no authority, or whether it's autonomous or simulated proxy. So these things we can use in order to kind of determine in our logic, what do we want to do? So in this situation, this is setting up some input, and input is something that only runs on client or standalone if you're playing single player. So you can go ahead and you can call functions like is dedicated server. And because we know that input doesn't get done on a dedicated server, I could just say not, a Boolean not here for, so I'm just trying to find the not icon, there we are. I could plug this in and that would do the input if it's not a dedicated server. So you can use a bunch of these helpful functions in order to allow you to gate logic. But you can see here I was using is locally controlled, and is locally controlled is a convenience one that pretty much does that. If we open it up and look at the code, it just calls is it a local controller, and if you go into this you can see the rules of what it will actually return. So it returns true in these situations. So is it standalone, is it client, autonomous proxy, and if it's not autonomous proxy but there's authority, then it'll say true as well. So you can look what they do, but ultimately there's a bunch of these different convenient functions in here that you can try and use to make it easy for you to branch your logic in your graph. So you have has authority, you can use not has authority as well. You can do dedicated server, and obviously you can do the invert of that if you're interested. Locally controlled I just showed. Can execute cosmetics is an interesting one. So execute cosmetics is basically, is it standalone, a listen server, or client? Because they're the only ones that are going to have a viewport and a player for you to actually see or hear audio or visual effects. You can check is it standalone, you can check if it's server, which will basically return true for any net mode other than client as well. So yeah, there's lots of different things you can do. I won't come up with the examples of each of them, but it's worth knowing that you do have that granularity that you can differentiate it. Okay, and finally then, the common mistakes, there'll be more of these that I haven't thought of, but one of the things I see quite often in logic is we get a player controller or pawn by an index. So if we go get controller or get player controller, you can see that we have this one from ID, and that allows you to determine an ID. Now in single player games, you can call this, and this will get you the player controller that is controlling the game. The same with get pawn, you can call that as well. I think I might have brought up the wrong function there, but regardless, it is possible. I just don't want to find the function for us right now while I'm explaining this. So the idea is in a client, or like a single player standalone client, then you're going to only have one player controller and probably only one pawn that's being controlled at the moment. And so it's fine for you to say, get me the pawn in index 0, because there's only one pawn or controller. Now, when you branch that logic over, or bring it over to a networked environment, that's where you're going to find difficulties using functions like that. Because if you think what happens on a server is created. It's just a little, think of it as a terminal file. You don't see the game, just black window with some white text. And it doesn't need any players. It'll just run on its own. But then when a player requests to join that via URL, it will create a connection for it, create a player controller, and allow that player to join that game. If another player comes, it does the same thing. So the server is going to have index 0 player controller for the first player that joined. It'll have an index 1 player controller for the next player that joined. And so it's going to have an array of player controllers that you can access. But the problem is 0 is no longer going to be relevant. It's only going to be the first player that joined. So you want to avoid any logic that's running on a server where you're accessing like a pawn or a player controller by its index, because you're not going to know which player's in which position typically in that situation. The second thing that I've seen, which is don't replicate deterministic data. And this is just a rehash of the point I made earlier about a door, where if you have a door that you want to open, that opening process is deterministic. It will do the same thing each time. And so instead of replicating all of the changes to that rotation, we can instead just replicate and say, hey, the door's open, and let the client do the rotation, and it means we're sending a lot less data over the network. I've seen it thing with timelines. So timelines are like a node you can use in Unreal where you can provide a curve to manipulate data over time. You can use that timeline will exist on server and client. So you don't need to feed a replicated value through a timeline and have the changed values sent over the network to everyone. Instead, you can just say, okay, I'm starting my timeline, tell all the clients about that, and then they all manually change that value together. That's a common way to prevent having to send too much data over the network. So yeah, hopefully this has been useful as an insight into kind of a lot of the mechanisms around the Unreal flavor of networking. There will be a second part to this where I go through a tutorial in the editor where I build up an example and we get to learn about it that way. But yeah,